Hello and welcome to our webinar. I'm Matt Griffin, Director of Community Development for Ultimaker. So for this webinar, we're going to focus on the food and beverage industry and the positive benefits of adopting additive manufacturing that we have been learning about from our customers, working closely with them over the last couple of years. We don't yet know what this new normal will mean for the global economy, but what we have been learning from our food and beverage customers is that the food and beverage manufacturers themselves are facing bigger challenges than ever. We will explore the potential impact of additive manufacturing and show you exactly how you can be a game changer with 3D printing yourself. Here's the rough schedule of the session. First, we have an introduction to food and beverage, the state of the industry. Then we're going to go through 7 proven examples of 3D printing applications that we think will really make a difference for you. The third section, we're going to show how to identify your own applications using the Ultimaker method. And thankfully, we have Jeremy here who has done a lot of this work, and it's going to be a real pleasure to see how he thinks through this with live customers. The next section is what does the future look like? And finally, we will be answering your questions live. So a little bit of housekeeping before we get started. The runtime for this webinar will be around 40 minutes, and we might go over depending on your questions. There will be a Q&A at the end, but you're welcome to ask questions at any point in this entire webinar. Just jump into the chat box in your browser. We have team members who may be able to answer your questions along the way, and we can also collect your questions for the end. If you'd like to watch this webinar again after we finish presenting this to you in this session, we're going to send an email link out to this video so that you can continue to explore this and take notes, and so that you don't miss anything. So I'd like to introduce our guest to this webinar, who is Jeremy Avers. Has been an application engineer for Ultimaker for the past 2.5 years, and for the past 2 years has really focused on food and beverage and has a lot to offer there. He's been traveling around the world and has seen the inside of plants all over and really seeing how 3D printing can make an actual impact right there in the places of manufacturing where we had hoped to make a difference. He's brought a number of the solutions that he's helped to develop over the years with him. So we're going to have some really excellent show and tell items to give you a sense of the parts that really do make a difference. And he's quite an expert at working with these customers to help them identify these opportunities. He's going to bring some of those ways of thinking and some examples of how he has helped people into this session. So even though he, like myself and probably a lot of our viewers, have been at home for the last couple of months, he's also been out there in the world everywhere as well, because he's been taking some of the site scans and site visits that he's been doing in the past, and he's been doing them virtually and helping folks. So I'm looking forward to hearing about that. So Jeremy, welcome very much to the webinar, and thanks for joining.
Yeah, thank you, Matt, for the nice introduction. When you name this, it's indeed quite impressive, and indeed due to the travel restrictions, I cannot travel. Otherwise, I would probably be at some sort of bounty island inspiring people with 3D printing. But unfortunately, we have to do it like this. But what I would like to discuss with you during this webinar are, of course, the benefits of 3D printing within the food and beverage industries. I will share you different kind of applications. I've been working together with different kind of clients, solving different kind of challenges as well. And of course, I will share with you some Ultimaker way of identifying applications and of course what to focus on.
Excellent. So a great place to start for this whole discussion. Let's talk about the food and beverage industry and the difference between food and beverage and other consumer goods. What are your thoughts about that, Jeremy?
So if you compare the food and the beverage industry with other consumer good industries, of course the industries are different and you really have these industry specific challenges. But throughout my experience, I've seen that all of these facilities have production methods, production processes, quality control. They even have issues with lead time and also costs. So you see that throughout all the different industries as something similar. But if I must mention a big difference is the quantity of the output of these facilities. So if you have, for example, larger consumer goods, you're talking about an output of dozens of products, for example, a day. But in the food and beverage industry, in general, you'll be talking more about hundreds and even thousands of products being produced every day. So I think that's the main difference between the food and beverage industry and other consumer goods industries.
And while I think you've pretty much answered this in your description there, would you say that this webinar would be applicable to those who are manufacturing experts outside of food and beverage?
Yeah, indeed. I think this webinar is very interesting for also people outside food and beverage. I mentioned there are different processes, different challenges, but there are also very similar issues people are facing with across different industries. So I think it's really, really relevant.
Well, speaking of taking a look at what's happening right now in industry, let's do a kind of a state of the food and beverage industry moment here. So to kick this off, this is a field that's been changing a lot and quite a bit even before these very disruptive last few months with COVID and changes in our ecosystem. So some of the things that we had already been seeing are rapid changing market dynamics, changes in consumer behavior, increased costs at various stages within the process, and also struggles with logistics and trying to maintain the supply chain continuity seems to get more and more challenging. Jeremy, you've had some feedback from customers about some other specific ones that you'd like to include. What are some ones that you would highlight for right now?
Yeah, during these bizarre times, you see that people are being cautious, but companies are also cautious. You don't know what's going to happen in the coming months. So you also see that really the customers try to keep cash in as much as possible and to really postpone like the bigger expenses. But on the other hand, you also see a lot of new opportunities for applications. So probably you have seen on social media as well, people are printing door openers, for example, to still enable also a safer environment for the operators, for example, in the food and beverage industry. And still they are trying to maintain this higher overall production efficiency, because if you have a lot of short stops and downtime, you cannot produce your products, and at the end you can lose revenue as well. There's still a high demand for products, but also there are some shifts. So you see that customers are really focusing on these high demands and are less into diversity of products. So they really focus on their high demands as their need number one, and the diversity is less, basically.
And we've been hearing updates from the field from our many customers throughout manufacturing about these times and what's possible. So during these next couple months, we would love to hear back perspectives. Maybe there are questions and things you can share in this webinar to help us understand how you are tackling all the changes and adjustments in this ecosystem. Now, the next part of the webinar is my favorite. This is the opportunity to really dig deep into a couple of the solutions, the areas where Jeremy and his colleagues have been able to go in and make a real difference helping our customers. So I'm so thrilled that we have Jeremy, who has helped develop and identify a lot of the key applications that we're going to be sharing here. He has with him some of the printed parts to help illustrate and suggest what is possible in this field. So we're going to go over 7 game-changing benefits for 3D printing. And the list here is safer working environments, decreased lead times and costs, increased uptime, faster changeovers, faster time to market, improved ergonomics, and increased efficiency. And within each of these, we'll get to dive deep a little bit, and you'll get to see some examples of some of the things that are possible. We're going to kick things off with safer and healthier working environments. Now, it is worth mentioning that this was already a very powerful choice for a lot of the manufacturers and plants that were exploring 3D printing. They were already able to find a lot of interesting things in these areas, and now there's even more updates. Jeremy, do you want to share some of the safer and healthier work environment applications that you have been identifying?
Yeah, definitely. First of all, of course, talking about applications and what kind of impact it had on these companies, it's the most fun to talk about, and especially for this topic around safety. Because when I saw this for the first time, I was really like, wow, these people are really tackling safe situations with 3D printing, with our technology. So first of all, that was amazing, and I wanted to learn more about their mindset and why would you tackle these kind of applications. So the application I would like to start with is this Loto equipment. Within production facilities, you have these Loto equipment to make sure that during maintenance you close off valves or switches, so other operators cannot enable the machine again, and some accidents might occur. But most of all, these Loto equipment is universal, so you have different types for different valves and switches, and this can lead to quite some chaotic adjustment of the machine as well. So what this client did is really make customized Loto equipment for their machinery. So whether it's like filling the bottles or even packing them on pallets, they have these Loto equipments basically everywhere. I will just briefly demonstrate how it works. So basically it's a flap which you can rotate, and in a normal situation it is positioned on a machine like this. You will see that there is a yellow tag and also with a QR code, so operators can scan the instructions as well. There will be a padlock in here. There's a hole here, so people cannot put the Loto system on when it's not needed. When it is needed, they unlock the padlock, they shield off the sensor, which is probably here in this location, so you have a sensor and a door. If it closes, then the machine knows, okay, I can run. But if you obstruct that with this, for example, it cannot enable itself. So you put the padlock here again, so you know that it's locked and cannot be enabled. On this side, you see a red indication, also that the Loto has been applied and you cannot run a machine. So this is really something safe.
And for our customers who maybe aren't manufacturing experts, so aren't familiar with Loto as a technical jargon, it is lockout, tagout. And as Jeremy was demonstrating, this is a key procedure used in plants all around the world to make sure that, if service is needed, there's a solution to make sure to communicate that well. Yeah, thank you very much for sharing that solution.
Exactly, and a nice detail is that it's a nice bright visual color of the Ultimaker Tough PLA. Another application I would like to share with you is when people are doing maintenance, they need to crawl in a machine to access certain points of the machine. And in some cases, like a chain is not covered well enough. There's grease and there's movement. So we would like also to create a safer working environment there. And therefore we created this chain cover. It's a really simple part, you can print it really easily, and basically this protects the operator from getting hurt by this chain for the sharp edges, for example, and also protects the grease on the chain from collecting dust. So something as easy as a chain cover can also be easily 3D printable.
And Jeremy, you had been mentioning when we were talking before that this world is changing in food and bev in specific, even further in the wake of COVID-19. Do you want to share some of the new innovations and steps that factories are exploring?
Yeah, definitely. So up to the point when COVID-19 hits in, people were developing these applications for their facility, but suddenly there was a switch. You saw that companies, they realized, hey, we have this 3D printing technique, and we can also use this to create a safer environment for the operators in ways as, for example, printing the brackets of face shields, and also printing door openers to make life more safer in the facility. And that was really great to see that switch and that people really cared about their operators. And the good thing besides this is when they made sure that the internal environment is safe, they also supported local hospitals with these kind of face shields, for example. So that was amazing to see that switch and also that flexibility with 3D printing.
Excellent. So our next application focus is decrease lead times and costs. Now this is one that's particularly popular among our customers. In fact, probably one of the main reasons that 3D printing was sort of first identified as being a good solution for manufacturing. Jeremy, do you want to share some of the ad hoc and redesigned parts that you've been involved with
Yeah, definitely.
in the factory space?
Yeah. So normally we talk about lead times of 2 to 4 weeks, but I was quite amazed when I was in an African country, quite in a remote area. We were looking for applications, and suddenly somebody popped up. Yeah, this can be a really nice application, because in general for our spare parts we have a lead time of approximately 9 months. So can you imagine waiting 9 months for your part to arrive, because it's that remote and you have all these kind of logistical issues. So that was the point. I thought, okay, let's take this as a challenge and really get the most out of these spare parts. And one application which is really nice to share with you is from a pack spinner application. So imagine you have a stream of a pack of bottles binded together before it's being palletized. It needs to be reorientated. And then you have these kind of poles coming down. With this application, the pack of beer bumps into this, rotates, and then it gets palletized. So the interesting part of this one, the original part looked different. It was an aluminum core with some rubber molded around it. So it was a manufacturing technology. And what we did is we really looked at this application. So the old one was too hard. So if you have some inconsistencies in the glass, for example, the bottles could shatter and you could throw away the whole batch which was being palletized. So the dampening effect was really important. What you saw in the beginning, when they didn't have 3D printing, they replaced these parts with, for example, a piece of foam with some tape. Didn't really look professional. So we tackled this with Ultimaker TPU95A, which is the flexible material. And we tried different kind of infills to get this dampening effect. What you see here is the triangle infill. So when I squeeze it, you can see, oh, there's a nice dampening effect. And the cool thing in Ultimaker Cura, you can change the pattern to, for example, a grid to have an even sturdier part. And the last one we tried is the gyroid, and that's really the most sturdy one for this application. And you can also play with the infill density to get even more flexibility, for example. And that was really
I love that example.
Yeah, a really nice application, and it's cuts down cost and lead times as well.
I love that application because not only was it a way to first address fixing a part that was expensive and time-consuming to replace, but they ended up identifying a much better way to solve the problem, and so they have a solution going forward, which takes us to our next application area, increased uptime. So not only do you have the opportunity to replace a part that you know is a heavy wear item, like in the previous example, but you have the opportunity to make fixes across automation line. Jeremy, do you want to share some of the increased uptime examples that you brought?
Yeah, definitely. So when I'm talking about uptime of parts, I'm also talking about having fast changeovers, for example. I have a nice example here. This is from Gerald Schubert. And I've seen a production line running 15 different kind of products on one line. So in some lines you have one product coming through, get labeled, getting packed, but on this line there were 15 at the same time. So how do they do it? So they really looked at 3D printing and created this system of modularity. So for example here you have two of these parts. They are fixated on a module, a transport module. And the good thing here is that these parts are swappable. So you print your format, and you click on your format, and you can have different shapes on the same plate. So that's a really nice application. Different than this is also color coding. So if you want to switch, for example, to a different format, they use different kind of colors. So if you ask somebody, so if you would like to change this production line to run color number red, they only have to change the colored part to the color red, and then you can already set your format to that kind of batch you want to run. So it can be as easy as that. It's a really pokey-yoky solution, but really high valuable.
And these are solutions that there just aren't the same kind of flexibility in off-the-shelf solutions. So you get people working in factories and really understanding the problems, and they can get exactly the solution they want right there on site.
Exactly.
Let's explore automation lines even further in our next application area, load balancing and fast changeovers. So this is a little bit of akin to some of the efforts to optimize and make some replacement parts and improve things, but there are more implications. Jeremy, do you want to share load balancing and fast changeovers examples with us?
Yeah, sure. I was a bit confused with the previous topic, but of course, the fast changeovers, it's all about if you need to stop the production line and make sure it's suitable for the next run. So you run batch A and you want to run batch B based on the needs. So you need to do a certain changeover, because for some machines the height needs to be changed, or for example certain distance of the conveyor belt system. For this there are different kind of solutions. One I mentioned is with the color coding, for example with cylinders you put on the axis with certain heights. And you can even emboss, for example, with text, with dual extrusion. So you have a red part with black text on it. So for the operators, it's really visual, and they can immediately see what batch they can run with it. It can also be done with this example. If you have, for example, all these silver metallic parts, which you are currently running, and you know you're going to do a changeover in 2 hours, you already gather, for example, your box with inserts in yellow, because you know you're going to run the yellow product. You can stop the production line, quickly remove these parts, get the yellow parts in, click them in, especially for this modular system, it's really easy, and then run production again. So then you have a fast changeover.
Fantastic. Yeah, so each aspect of running an automation line, there are optimizations, there are improvements, there are solutions that are really best made, or at least informed, by those who are there seeing the line. And so companies can find these solutions and build on these solutions and share them around to their other sites. Another really critical application area is the next one we're going to talk about, which is leaning on a lot of the stuff we've already talked about, but extending it further. These are efforts to achieve faster time to market. Jeremy, would you like to share some of the options there? I know you've touched on several that contribute for sure.
Yeah, exactly. Because it's such a great application, I will go back to this kind of application because it tells the story really nicely. So faster time to market, you want to get prepared as much as possible for the run of your new product. You can have the new design, for example, ready, But of course, your production line also need to be finished before you get all your packaging in, and you need to start running the new line. So, for example, I'm running this format. It's a wide format I'm running, and currently I'm planning to roll out a new design as well. It's a competitive market, so I need to be fast. I already contacted the supplier for a new bottle format, and in CAD I already modeled, for example, this kind of product. It's a cylindrical product. I already printed, so whenever I have time and I want to run a new product, for example, I just switch it. And then you have your new format ready to be produced. You have different kind of applications for this, but this was the easiest to share with you.
And that achieving faster time to market is critical for a lot of our customers in packaging in general to compete and to bring consumers the things that they're wanting. And it's really interesting seeing those who are really getting into this. Some of the customers that Jeremy has been working with, we're finding lots and lots of solutions that they can explore. They'll take this even further. They will find other ways to bring in other resources, other sensor packs, and this kind of thing. So they start to make their own changes that really optimize what's possible. So let's talk about increasing equipment efficiency with the customers investing in really making their system run to solve the problems that they need to solve right there.
Yeah, exactly. So first of all, the operators always know exactly the pain points and then challenges of the line. They are working full time besides these lines, so they can really pinpoint, okay, here's a problem or there's a problem with this machine. And then now with 3D printing, they can really tackle these applications and come up with solutions. For example, this part is line extension. Can you imagine having a conveyor belt system full with products, with cans or with bottles, and then there are sensors to track down if the line is still full or you have like an empty spot, so the machine can stop before running production again. And these are basically metal rods in most cases, and these get pushed outwards when products move through. But if you have, for example, a bottle which tipped over and gets stuck in this rod, the sensor cannot tell the system that it's like either full or it's empty. So it will keep reading, okay, this conveyor belt is empty because the sensor cannot be pushed in. And for this, this client created an extension for this. So the rod is built in. It's built out of two parts and then afterwards assembled together. And basically this creates a bigger surface area. So this will lead outside the conveyor belt. So when a bottle falls down, it will just be guided across this piece and not get stuck in the sensor. And with this, you can really increase your equipment efficiency in a particular spot.
Now, we've talked a lot about lines, machines, and modules. Let's talk about the human part of the equation. Let's talk about ergonomics. A lot of our customers have been letting us know that there are opportunities there for tailoring things to the individuals working with them there to produce products, and there are a lot of opportunities. Jeremy, please share with the team here some of the ergonomics examples that you've been seeing.
Yes. So ergonomics, we see a lot in these production environments. You've got people which are more on the smaller side. You've got people which are more on the taller side. So no human is the same. No operator is the same. So for example, hand size, you've got people with some bigger hands and with some smaller hands, but they still operate the same kind of tools. A nice tool, which is an ergonomic tool, I have here. And this is basically for a capping module of a production line. The previous situation, they had a wrench, which was only one side of this application. They need to fixate it on the valve. And then for some operators which are not as strong, they need to slam this wrench with a hammer, but you can imagine if you miss this wrench, you can either hit the machinery or even hurt yourself. You slam on your fingers. So that's if you want to exclude this situation. They were thinking about making a more ergonomic tool for this. So they basically decided to go for a different system, and instead of having just one wrench, they have these clips they put around the capping module. They also incorporated text, so this says tighten. You have a tighten and a loosen ring, you put it around, and then with this system it has little teeth here and also teeth here, so if you use this tool you can loosen it or tighten it in a better fashion. And this is a really nice example where you go from a steel tool to a polymer tool, and this is more lightweight as well than the metal one.
Well, that takes us directly to the last one of the application areas we're going to focus on, which is replacing metal with plastic. Yeah, that is a tool that I would have associated with metal, just sort of seeing it at a glance. And it's amazing hearing what's possible to do with polymers these days. Do you want to share some of the solutions that you've been hearing about where polymers are actually a better choice even than steel?
Yeah, definitely. This is one of my favorite. It's called the can pusher. Imagine if you have one stream of cans coming in the machine, and it's divided over 3 conveyor systems. So one is going through, one is put in the second line, and the other one is put in the third line. So this basically pushes these cans towards these lines. And the original part was about 1/3 of the height of this part, so there was not that much contact area with the can, and it was also on the top. So you can imagine that these cans might tip over and lead to jammings in the machine. And what we did here is make the height higher, so you have more contact surface area to push these cans, and it's more lightweight as well than the metal part. And also a nice feature about this, we took this a step further. So with Ultimaker Cura, what we did is we changed the outer wall extruder. So the inside we print with a different color, and the outer wall we also print with a different color. So when you run this through the line, what you will see here in this example, when it starts to wear down, you will see that the outer layer is wearing off. And because we use this bright red color, you can see this coming through. So when this part is running through the machine, the operator can check at certain times if he is seeing, for example, red parts coming through the outer layer. And when he sees it, he can already start printing a new one. And when they need to do a changeover, for example, they can immediately swap this part because it's getting worn out.
Excellent. So that was the 7 application areas that we wanted to explore here today in the webinar. There are even more potential places for applications to be found, but these were 7 we're really confident in. And taken as a group, the bottom line is that 3D printing empowers engineers and operators to solve more problems. Jeremy and I were talking before the webinar here, and he had an amazing story that he wants to share that really demonstrates how this all sort of comes together. Jeremy, do you want to share your story?
Yeah, so this story really shows the power of 3D printing. So I went to this client and I did a 3D printing workshop and showed them how to identify these applications. And in a later stage, an operator was doing his normal day shift. He was walking around doing maintenance, and then suddenly he spotted basically an application, a machine where cardboard boxes are being fed in the machine, they're being set up and filled, and he saw that the grabber didn't grab the boxes good enough. You got different sizes, so sometimes it slipped out, and that caused jams in the machine. And what he did, he really took this as an application. Okay, maybe this can be a challenge for me and I can really show this power of 3D printing. And he was already inspired by the workshop. So we went back to his office. He started off CAD and he started drawing this part, but then making the height a little bit higher so it has more surface area to push in the cardboard boxes. He sliced it in Ultimaker Cura and then started the print immediately. And then he continues his normal day shift. And then a night shift arrived and he mentioned, hey, I got these improved parts. So now you're gonna run the night production. Please swap these parts. So they swapped it. And then during the night shift, the new parts were already implemented in the machine. And now the issue was completely resolved. So that really shows the impact and the power of 3D printing. So you identify an issue, you create a model for this, you print it, and you already implement it in the next shift.
It's amazing how nimble that solution was and how that team's able to solve problems so quickly. I find that story really helpful. So thanks for sharing that. So now let's shift our attention to how we can help our viewers to identify their own applications. Let's take a moment to consider all the applications discussed so far. So, Jeremy, why don't you walk us through a virtual site visit? Help us experience the process you go through with customers to help them identify the most promising challenges for them to tackle with 3D printing.
Yeah, definitely. So imagine that you're walking through the facility, you see and hear all these machines roaring around you. And basically, I'm like a scanner. I scan different processes. I see machines moving. I see parts moving. I see operators doing their thing. I can see operators doing their maintenance. And immediately, I start asking myself questions and asking operators as well. And basically, on everything what I see and what I hear from operators particularly, I take into consideration. And then I make, for example, the decision, okay, what would be the gain for this application if we 3D print this? Will this maintain, for example, the efficiency of the production line? Would it make the job of the operator easier or more fun or less of a hassle? And of course, also does a certain application ensure the safety of the operator? So that's one of the criteria. So it has, like I think about, is this a high value application for the operators and for the company for the process? And on the other side, I think about, okay, how complex is this application? Is this a low complex application? Because that's what I go for. Is it easily designed, for example, by the operators itself, or do you really need to have a specified designer or an engineer? Can the application be used in a normal production environment, for example? And are there no safety compliance requirements attached to this part of the applications? So basically, these two criteria are the sweet spot of what you can achieve with 3D printing. So you have these high gain, low complexity applications. So on a short amount of time, because it's a low complexity, you can have the highest gain, because the gain is the highest. So you can bring the most value in a short amount of time. So that's really a focus. And then you also have, of course, high gain applications which have a higher complexity, but you can do this in a later stage when you gather, for example, more knowledge on CAD, on Ultimaker Cura, or even on the certain materials which are available. And the low gain, high complexity applications you can do, for example, in a future stage. But these are more the nice to have applications and not really the low hanging fruits, as we call it, the high gain, low complexity applications.
I think this is really important for our viewers and our customers to know. There are so many things you can do with 3D printing, and these are the ones that Jeremy and his colleagues have really found is a place to start that really helps you amplify and accelerate your adoption of 3D printing and solving problems with it. So let's take this one step further. So no doubt many of our new and existing customers watching this webinar would love some more of your tips for places to start. Maybe they figured out the scope now, thanks to the last slide, the high gain, low complexity requirement to get started. But what are some pieces of advice that you could offer them so these manufacturers can really get started with their facilities immediately.
Yeah, what I would advise them to do is really take a look at all the processes happening in the facility and also really talk with your operators. The operators are working full time in these environments and they know exactly what the pain points are in the production and what can be solved or to make their job more efficient. And there are a lot of different application challenges as well, which can be solved with 3D printing. You can think of just the maintenance tools, for example, ergonomic tools, which I showed as well in the applications, transport tools, so tools which transfer, for example, certain products, disassembly tools, assembly fixtures maybe even, to make sure that your workpiece is nicely firm while doing maintenance or assembly. You can do cable management, or you can do quality assurance tools, so you make sure that your, for example, your labels are within the specs which you set in the beginning. You can create tools for that. So that's more application based, but you can also take the challenges as your main focus. So if you have tools which are heavy for some operators, or they cannot reach certain areas, so you can do ergonomics, of course, functionality of certain part. Maybe they solved it another way, but it might not be the right way in the end. Safety concerns, I also shared with you the Lotto equipment, and for the rest, increase machinery efficiency, for example.
Thank you very much for those tips, Jeremy. Now, let's take a moment to talk about what makes Ultimaker the ideal solution for food and beverage manufacturing. First of all, our expertise. We've helped hundreds of companies to develop industry-proven applications. You've seen a couple of them here during this webinar. Reliable solution. We have thoroughly tested hardware, materials, and software. Easy to use. You and your team are able to start printing after a 30-minute onboarding. Open material platform. You have the freedom of material choice, giving you the most application integration available in our ecosystem. Integration. Use any CAD software, easily fit our solutions into any workflow that you have. Probably what you're using right now will work great. Easy ROI. This is an affordable solution, and you get a lot of value out of your Ultimakers. Scalable. 3D printers are small and benefit from modular setups anywhere in the world. You find a solution and it's working for you, you can probably deploy it elsewhere or scale up your amount of production capabilities wherever you want to put it. Now let's go back to our story of food and beverage industry, and let's talk about the future. Let's talk about where things might be going next. So, Jeremy, you had a couple of suggestions I thought were really telling based on all of your travels, all the plants you had a chance to visit and really walk through and see how they functioned, and all the virtual tours recently. What are you seeing as sort of the next steps for 3D printing and food and beverage industry?
Yeah, so you already mentioned I'm basically traveling the world and inspiring people to start with 3D printing in the food and beverage company. And indeed, it's already happening. Companies are rolling out 3D printing within the company globally. They start to develop their own competence centers, their own 3D printing hubs, so they can share across plants, for example, what kind of applications did they develop, and can they scale this across different countries. So that's one you really see already happening. It's not in the future, but it's already happening, and it's getting more and more. Also, what you see is that these big enterprise customers are implementing 3D printing and directly also start to talk with Tier 1 suppliers to get them involved in this whole transformation through 3D printing. So you might see that if you need a spare part, instead of shipping these parts, you might contact your supplier. They provide you, for example, a print job, you print it on site without logistical issues, and you implement this. So that's also what you see happening. Of course, you've got Gerald Schubert, which have these databases. So whenever a customer needs a validated print file, for example, digitally, they can send this to a database, and when the customer needs this, they can click and print the part directly next to the production line and already implement it after printing, for example. And for the food and beverage industry, if you have parts which are really in direct contact with your products, with your food, for example, there are partners such as Eric's, which can provide 3D printable, 3D printed parts, which are printed in a clean room environment. So we also see that that's being enabled currently.
Those are really helpful projections for where we might be going in the future with food and beverage. And certainly this tracks out in the various conversations I've been having with our food and beverage customers.
Exactly.
So we really hope that the webinar contains a lot of value for you, a lot of examples of application areas you can explore, some thoughts about how you can go and adopt this stuff in your own facility, and even these projections about the future. We have more to offer. We right now have a playbook, the 3D printing playbook for food and beverage manufacturers that we're offering now at ultimaker.com. And this goes into more depth on this topic than we were able to do here in these short minutes. And it contains hidden ROI of 3D printing, which really can not only help you see what will be helpful to you, but maybe help stakeholders where you're working understand why it's worth adding this tool into how you work. And the playbook also contains specific questions to ask that will help you discover more applications. Thank you so much for watching our webinar. We've been collecting your questions throughout the entire webinar, and stay tuned for the Q&A period that's going to begin shortly. Now, if you haven't sent in your questions yet, now would be an excellent time for you to do so. You can enter them right via the chat box right now, and we will queue them up, and we look forward to answering your questions.
All right, so hello and welcome to this live Q&A for this session. I hope, of course, you liked the webinar and that you're inspired to kickstart 3D printing within your company. Let's dive into some of the questions you've asked during the webinar, and let me answer them for you in this section. So I will start off with the first question. The first question is from Shingi. Hello, Jeremy. Great presentation. The question, we would all like to know that food safety is the most critical point in food and beverage industry. That's true. Are there any limitations that 3D printing can't be applied for cleaning food and safety reasons, or 3D printing can actually help in this point? Indeed, that's always a topic which comes back also when I do these kind of workshops. How food safe is 3D printing and what are the possibilities? What I do mention is that within a production facility in the food and beverage industry, you see a lot of different processes. So you see, for example, loading in of the packaging, of course loading in also of the raw materials and the raw beverages, for example. And what I see is that there is one part of the production where these raw materials and this packaging comes together, and most of the time, for example, in a beverage company, you have the bottles which come in, they get cleaned, and right away they fill it up with the liquid which is intended to be positioned in this project, and then shielded off directly after the filling. So you see there's only a small portion where it's really critical to think about food safety and compliance. But it's a small part, because the biggest part we can cover with 3D printing, like all the mentioned tools from the webinar. You also got different materials, which are, for example, antimicrobial, which you can use. I've seen customers using different kind of coatings, or indeed focusing more on the processes around where actually the food is being packaged. So there are a lot of different possibilities for 3D printing where food safety is no issue. All right, then I go to another question. How do you design parts to be printed, the exact size, shape, etc.? So all these applications, of course, we print with 3D printing. They need to be designed. So what you can do for tolerances, for example, if you already know I need really a press fit, for example, or an intermediate fit or a loose fit, you can either already implement this in a CAD drawing to take an extra offset, for example, or you can also in Ultimaker Cura, what I do personally, that I use, for example, now we have the intent-based profiles in Cura, where you can, for example, select the engineering profiles. These are pre-configured profile settings to optimize also for these kind of fittings for 3D printing your applications. And what I personally do, that's a tip from an application engineer, to use horizontal expansion, for example, and there you can incorporate a certain offset while slicing your model. There's a new feature which is whole horizontal expansion, so this only focuses on the holes, for example, to make them slightly bigger, slightly smaller. Sometimes I do some test printing to see, okay, if I print it with this engineering profile, does it suit my requirements and my application? If not, then I can do a quick iteration, and then it's good. So I hope that answers your questions. So there are possibilities in CAD, but also a lot of possibilities in Ultimaker Cura. And he asks, you mentioned about labeling parts with dual extrusion. What do you mean by that? So the Ultimaker, for example, the Ultimaker S5 has 2 print heads where we can print with 2 different kind of materials, 2 different kind of colors, and with a build material and with a support material. With dual extrusion, I mean, for example, when you have a certain labeler and you want to incorporate text for the operators to understand what kind of tool this is, indicate maybe the height, specify this. And you can do that in a 3D model. So you have your actual model, and with a different color, for example, you write in the name, and in Ultimaker Cura you can specify which extruder is being used for which part. And there you can really label your parts. Matabishi asks, I'm curious to find out, you've helped similar companies to adopt 3D printing. I'm also interested to have it at my center. So what we normally do, we engage with our clients. We have some calls to understand, okay, what are your requirements? What kind of products do you facilitate, for example? And based on that, we already make an estimation, okay, where can we add the most value? We can also do, for example, a benchmark print together with our clients to see, okay, now I have my 3D printed part. I will test it at my facility and get other people inspired as well to start with this, and then we can provide workshops, trainings, for example, to even kickstart more 3D printing within your center. So please keep in contact, so we can definitely help you accelerate 3D printing within your center. Stefan asks, where can I get more information on different models of printers? So besides the Ultimaker S5 and the Ultimaker S5 Pro bundle, we also have other Ultimaker printers. You can go to ultimaker.com and find out what other kind of printers we offer in our portfolio. We have a wide range also of different materials which can be printed with these printers. But on the website you find the most information you would like to know for seeing also other printers. Nick asked, are there any polymers with metal content so they can be metal detected? Yes, there are some materials which also incorporate for example, metal powder in it. You've got polymers with stainless steel particles in it. You also have polymers with copper in it, for example, to give it properties for antimicrobial. Yeah, so definitely these are available.
And if it has the right diameter, it can also be printed with the Ultimaker printers. So there are definitely materials out there which have a certain material content. Also, our website, the material page, allows you to look for these kind of filters as well. Jim asks, I was wondering if there's a list of suitable materials for this industry. We from Extruder have food-safe materials available exactly for these kind of application. Okay, so that's really good. We have an open filament system. As I mentioned, when it has the right diameter and fits the specifications of the printer, you can print it with our printer. There are a lot of different materials which are already verified to be printed with our printers. For example, in Ultimaker Cura, we have the marketplace, and if you browse that, you can see all the verified materials, also from third-party companies, to be printed directly with our printers. Also specified for this food and beverage industry. Then it asks, that parts which you showed where was interesting, but how does it work? Do you need experiment with how much wear it takes before replacing? So I think you were talking about this can pusher where we extruded the outer wall with a different color. So outer color can be anything you want. At least it has to be in contrast with a different material, so you actually see something. When you do the outer wall extruder setting, it will be one wall. So depending on what kind of print core you're using, you can verify this. So you can do it with a 0.4 nozzle core or a 0.8 nozzle core if you want to have a bigger outer layer as well. Or in CAD, you can do, for example, the outer wall, you can give it an offset and cut it into two parts. So if you have the core and the outer surface, and then you can really specify, I want it to be 1 millimeter, I want it to be 2 millimeters, so you can even go beyond the nozzle size. And in Ultimaker Cura, you can easily select which part needs to have which color. Sean asked, what are the main characteristics of 3D printing applications that can replace metal? How do I spot them? So normally what I say, for example, or what I do when I look at certain processes, indeed when there is steel, I take a look, okay, what kind of steel is it? Is it really stainless steel? Is it really needed as well? Some people say, yeah, this part it's really over-engineered or it's really heavy. Then I can say, okay, does it really need these kind of requirements? Is it just to guide something, for example, so it doesn't have to apply a lot of force on a certain application. Indeed, as I mentioned during the webinar, making applications more lightweight, you can easily do that with replacing steel. Yeah, so those kind of considerations you can take for replacing metal applications. Frank asked, not everything on that Lotto safety device was 3D printed. How do you decide when you should use metal bolts versus 3D printing them? So yeah, the Lotto equipment was actually also produced with nuts and bolts because they needed to fixate it on the machines. So all the different variations they have, they apply these nuts, for example. Here you see at 4 points it's being attached to the filling line, for example. And then with a shaft, they make sure that the hinge works properly. And for the rest, for the text, because they needed more colors than 2 colors, they just printed the labels. So in these kind of situations, you can combine 3D printing with nuts and bolts to act as fasteners, for example, and labels to make sure that there's sufficient information on the application. Paul asked, are there any 3D printed parts that plants can always benefit from? What do you look for first on the side scan? That's the best place to start with 3D printing. When I start, I always make sure that I walk up to the operators doing their maintenance or looking out for the production line and really ask them, okay, can you show me the pain points you have doing your work? So is there a spot in this production line where it's not really moving fluently, or you see a lot of short stops or full stops, then we go to that certain location, we observe what's happening, and with my technical background I can say, okay, what I see here, because there's quite a steep slope, for example, we need to make sure that this transition will be better, or it's guided in a less efficient way, or I take a look at his tools. Yeah, so that's basically what I look out for. I would like to close off with that question for this session. I hope you got inspired with this food and beverage webinar. I hope you enjoyed it as well, as much as I did. If you would like to have more information, go to ultimaker.com, our website, to find out more information. There will also be a playbook available where you can read all of these insights as well, communicate it within your company. We are always there to help you out and really accelerate this. And after this webinar, there will be a quick survey. Please fill this in so we can make these kind of webinars even better. And for the rest, I wish you a good day. Thank you.